Hey everyone, Paul Daniels here again, and another nightly programming fix. So, any of you who have been watching my videos for a while will know that I occasionally get the situation where I end up recording the top of my head and the top of the microscope when I really want to be recording what's under the microscope. And unfortunately, when you're in the middle of these sort of recording sessions, you don't always look up at the screen to see what's actually been recorded, and subsequently you end up losing a fair bit of your footage, all because you didn't press the button to say switch scenes in Open Broadcaster. So I was thinking about how I could solve this. So at the very least, when the microscope is being used, that the Open Broadcaster would switch over to using the microscope scene. And I thought of a few different things, like maybe a contact switch on the microscope, so that when it swings out, it presses, say, like a micro switch. And I thought maybe looking at if I could do it programmatically I noticed on the top of the microscope there is a blue LED, and I basically do not have any other blue LED light sources anywhere. And so I was thinking maybe Open Broadcaster had a filter where it could detect that there was a blue LED, and if that was the case, switch over to the microscope. Unfortunately, that was getting a little complicated, a bit CPU intensive, and there really wasn't a direct way I could see of doing that in a hurry. So eventually I came up with a solution which doesn't require switches or anything, but still does require some electronics, and that is one of these things. Now this here, yeah, we're not going to see it too clearly. Sorry, get up really close. You don't want to come up close? No? Oh well. You can see all the spots on my nose instead. So what this is a 3-axis magnetometer or whatever. Let's just call it a compass sensor. And even though it's 3-axis, we can still just use it for 2. So a planar type compass, which is what we want. And the idea is, I put this on top of the microscope, and then as you rotate the microscope, the arm that holds the head, as you rotate it out from its retained position into one where you're going to use it, the compass heading will change. And there'll be a range of degrees where you consider to be using the microscope. So that's the idea. So using this, and this is an I2C device. I just bought this off the internet. There's no point me building my own with these when, I mean, this is so cheap. It was like $6 or something. And this here is a I2C, I squared C, I can't say I squared C, I2C interface that goes off to USB to the PC. Now in my case it's going to be Linux. If you're on Windows, it sucks to be you. I don't know if I'll do it for Windows, but this is just for me because that's who I'm planning on using it for. Now, coding this thing was an absolute pain in the butt just to get started. There's plenty of I2C libraries for Raspberry Pis, for Arduinos, however you pronounce that. Personally, I just think of it as AVRs, although I understand the Arduino is a nice little layer over the top of all that and encompasses multiple different chipsets now. But originally it was AVR. And that's all great, and all the code that I could find on the internet dealing with particularly this chip here, because this one is actually meant for an Arduino setup, it was no use to me. Because Linux, while it does have an I2C subsystem, because obviously all the sensors in the computer, it really doesn't have a lot of documentation because it's not something that a lot of people use on the hobby sense or anything like that. So a lot of it's buried in the kernel code and things like that. And there were a couple of little snippets, but it was nothing really easy going. And the other thing is, and I've noticed this regardless of what platform you're using, I2C devices as a general rule always have their quirks. It seems every single damn one of them. You think you got 95% of it sorted out, and then something's just not quite right. And it's because there's a little quirk that the designer of the chip did, either to be more efficient or cut a corner or whatever, and it catches you out. And I swear, there's no such thing as a standard I2C device. You've always got to get around the quirks. Anyway, so I'm going to go through the code a bit and sort of give a rundown on what I've done. And also we've got to improve this code because we've got to get ready to make it an application that I can use. The idea being is this application will run in background while I'm running Open Broadcaster on the machine, and it will monitor the compass orientation, and then when it needs to, it will issue a keyboard simulation to make Open Broadcaster switch. I am aware of the fact that there is such thing as OBS WebSockets or whatever. I had a quick look over it. It's not quite what I'm looking for. I think it might be easier if I can just simulate a keyboard press, something like, Shift F12 or whatever. We'll see how we go. I haven't got there yet, but we'll see how we go. Alright, let's get into it. Need a sip of coffee first after all that. Yeah, lukewarm, nice coffee at 10 to 12 at night. Sounds good. And I've left half of it on my moustache. That's going to be, I'll have to wash that off because really disgusting thing. You eat dairy products and inevitably it gets on your moustache a bit. And if you don't wash your face properly, you start smelling like sour milk. It's disgusting. Filthy. So remember, wash properly. Alright. So, getting onto this, I ended up creating a whole bunch of I2C functions because I couldn't find a simple library in Linux to do this. It's the usual thing. When you create a generic library, it usually just sprawls out of hand and has way too many things for what I want. And the other thing is, this is a good learning experience for me. When I started this, I2C devices in Linux was very, unsure of what I was doing. When I was using these things on the AVRs, I'd just bit bash everything to do what I want. But different in Linux. I should point out the device itself, this is just a generic AVR Tiny 85. Fantastic little chips. Doesn't even need a crystal, and you can talk to USB through it. It's just brilliant. If I go to new message, there you can see, here we go. This is it here, little I2C to USB bridge, and it does the job very nicely. Alright. So I end up writing all these functions to read and write data, and they all fundamentally just use the open, write, and read file calls. Probably the hardest thing in this whole process was doing this 2's complement to decimal conversion for 16-bit. Mostly because all of these devices tend to use big endian code format, so your most significant byte is first, then as you read the data it gets to the least significant, whereas Intel chipsets, they use systems, they use the least significant byte first, and so you can just swap it around, and that normally isn't a problem, except that we're also doing the 2's complement formatting of the numbers, which means you've got to do a bit of bit bashing, and if you don't do that in the right sequence, you cause the whole desk to shake. If you don't do that in the right sequence, you just get gibberish data out. So I spent way too much time on this bunch of code here. Fundamentally, if you've got a negative number, then you got to go through all this mumbo jumbo. If you've got a positive number, then you just smack the 2 bytes together and you're good to go. Like I said, far too much time wasted on that. There are other quirks that I had to get around. Let's see, I've added a auto detect because on Linux there's, on this system I think it's like 9 different I2C buses, and so you got to try and find the right one, and this particular chip fortunately has a fixed address, so which in this case is 1E. I probably should change that. Let's be proper programmers. Who am we kidding? Proper programmers. I'm definitely not a proper programmer. Okay. And if anyone's going to say, oh, Paul, you should have done it this way, you should have done it that way, and it's like, yeah, I mean, there's a million ways I could have done this, but I chose to do it this way. And if people think they can do better, well, then by all means, get coding, bring out something better. Otherwise, shut the up. There's no shortage of people who think they've got better ideas but can't ever deliver on them. We need more people who can deliver stuff rather than people who say this or that. I'm sorry, I've been a bit vindictive here, but sick of the crap. That was the nice thing about life a little bit before the internet. Back when you had bulletin board type stuff, you could share stuff, but it was such a slow transaction process that you can get away with doing all your own things, producing a product without people like going, "Oh, what are you doing? Where you done that not right?" Just smack them out. Okay, I'm getting silly now. It's getting late. Alright, now what I've got to do at this point is I've got to make this application more user-friendly. So I guess the first thing I'm going to do is create a parameter parser, because we need to be able to pass in parameters like maybe what our bus is, or even though I have got an auto detector, there are situations where trying to auto detect can crash your system if you're unlucky. So in that case it'd be nice to be able to specify your bus. The other thing is you'd want to have things like what's going to be my starting angle and what's going to be my finishing angle for the turn on the microscope. What keyboard sequence am I going to want to simulate? Might have to do something like what xterm window we're going to use to send the message to, or where's Open Broadcaster. I'm sure there'll be other things. We need a debug flag. Always got to have a debug flag. Alright. Parse, parameters. Will we do globals in this? Or will it be naughty? Yeah, let's do globals. I don't know why I do this to myself. So that means now I've got to go up and define a global structure. And doing keyboard, what key we're going to press, that's a little complicated because you usually have compound keys, like you want something like Alt, F12, things like that. So I might do K mods, which is keyboard mods, that'll be bitmapped. But like, so 0 is Control, 1 is Alt. Oops. Yeah, these are bit numbers. 2 is Shift. That should do. And key. Well, I guess we'll leave it at that and see what we need as we go. I will probably put all this I2C stuff into a separate library later. It could be useful for future jobs. Like I do have one thing coming. Now, some of you might recognize what this is. Be curious. Leave a comment in the comments if you know what this is. Well, it's a project I'm going to work on. And naturally, what's this? Paul doesn't know how to program. He's got to cut and paste stuff from another piece of code. Oh, shock and horror. Yeah, you call it lazy. I call it saving myself extra work that isn't required. Wow, really can't type tonight. Alright, so we can change this to bus and go U-bus. With the bus selection, it's basically just a number from 0 up to 16 or something like that. I'll see if I can show you what I mean. I2C detect. So as you can see, we've got this like 318, so blah 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 blah, and we can see our particular adapter bridge is on bus 9. So that's what that's for. So we're going to make this the start angle. There's no point using decimal place or anything. It's just going to be 0 to 360. That's it. They can be inclusive, it's not going to matter. Yeah, we might do quiet and verbose. E can be for end angle. X6 I think should do it. Not quite. Now with the start and end angle, I'd say we're just going to go from, I guess, a clockwise rotation. So if you sort of go start at 270 and you finish at 90, then yeah, it's that top span sort of thing. So it doesn't have to be that one's less than the other, it just means it will go all the way through past the 0. Okay, start and what else do I have? Keyboard stuff. Not really sure how I'm going to pull this off. So this, we'll put in a scan code. I think I might have to make that a 16-bit value. I think I yanked too many keys there. I'm not pressing the keys directly. Bad of me. We're going to leave it just as a straight scan code for now. I have to put in the mod keys later. Just want to get this thing to somewhat work to start with. Let's see, all this stuff I don't think I need. This is all, yep, trash. So you should initialize that structure. -1. The reason being is because it's possible that 0 is a valid bus number, so we've got to go a little lower than that. Alright, so if we change the U bus to something, then it means we skip the auto detect. Yeah, I know some people put that the other way around, but too bad. A little bit of code replication here, unfortunately. Actually, I wonder if I can... Yeah, I could have done that differently. Let's remove all that. Let's remove all that. What we'll do... So we set this bid value to be the bus that we want to try. And then down here, let's say, so it's either going to fail or pass regardless. So I don't know if I do have to do anything special here, but I will make it break anyway. Alright, let's solve that. Well, this is where we do the verbose stuff. If probably should just hash define that. Yeah, go on, Paul, do it. Do it. Do it. Because naturally it will cause me trouble in the future. You spend a lot of time doing stuff that isn't actually pertaining to the core functionality of what you're trying to do. Yeah, all this user interface stuff. And it's not just for other people, it's for myself as well, because I can guarantee you in 2 days' time when I come back to it, I'm going to get confused. So I'm going to actually type in, bring up the help to see how I'm supposed to use my own code. It's not possible to remember all your stuff. Like that. If we turn on the debug, then we also want verbose on. That's what I was trying to do. So here we just should be able to go verbose. There are so many of these that I'm going to have to set to be verbose. This here is debug. When I was initially doing this and trying to find my way between all the different methods of using talking to the I2C bus, I needed to be able to see what the registers were having in their contents before and after I started to modify them. And so this is just, it's just a bit of debugging code. Well, it's very useful debugging code. Excuse me. I'm going to manually do this one. Trying to work out what I was doing, that's all. Don't need any of that. Okay. Yeah, definitely debug. I'm setting these as debug because when it's doing the auto checking, it tends to spill out a lot of this, and it kind of makes the people, if they're watching it, think there's a more serious issue at hand than what there really is. Yeah, let's see if this compiles. No, shame. Wow, really made a mess of things here. Wow, really did. G undeclared. Well, I must be overriding something there. Maybe not. Weird, I'm not complaining about the others. Oh wait, no, it's okay. Damn it. I know what's going on. Oh, that's a nuisance. What the problem is that it doesn't, the reason why it's complaining about it doesn't know what this gdebug is in this function is because we don't pass it through here, and it's not a global, true global. I'm somewhat disinclined to do that. So for now, because I really don't want to pass that in, because when I make this a more generic module, you're killing me. You're killing me. What am I doing? Gee, I could have just made it a pointer, I guess. That would have been, yeah. Two, 7, 3. Ah, it's globs. To 10. Same trash. Z set but not used, that is correct. We do not use the Z-axis in this because we're assuming that our microscope is going to be sitting flat, or at least the sensor is going to be sitting flat. So the Z-axis which goes up, that doesn't ever change. I mean, there is a little bit of, depending on where you are on the planet, your declination may change, but for the intents and purposes of what we're doing here, no. If you're going to be that pedantic, be my guest, but all we're going to be doing is we're going to move the meter to one extreme, we're going to make note of the angle that it's set, we're going to move it out to where we feel like we need to now switch over to being the microscope mode, and we're going to measure what the value is there, and then we're going to plug those values in to make it work. Let's see, 183. What's going on here? Why don't you like me? Oh, right, non-void. Yep, that actually should be a void. I've got nothing in there, of course. Alright, that's good. Okay, now, let's run this thing. I should be able to do it with no parameters and get... Wow, we broke it. Interesting, it worked. Alright. So we rotate this thing. So at the moment, so we're heading close to true north there. That's back towards me. And if we flip this, we should be at about 180. Yep. So there we go. That's pretty cool. If I turn it on the end, it gets it pretty damn confused real quick. But okay. So that's working, and let's see. Looks like it. Yes, this is why I didn't want all that trash there, so it makes it all confusing. I am curious why it didn't work at all. Like that. Well, why has it stopped that? Weird, it works with verbose. Huh. Why would you not work at all if I don't put any parameters in? Oh, I know why. Because it's expecting parameters. See this here? It's saying if there's nothing given to us as a parameter, then just drop dead. But in this case, we can run with no parameters, so that was an unnecessary failsafe. So here we go now. Is this right? That is technically correct, because the reporting of the angle is part of the verbose. Because obviously if we're running this under Open Broadcaster or with Broadcaster, we may not want any output occurring, we just want it to silently do its job. Which now takes us to the next bit. We need to make it so that it detects if the angle we're in is within the confines of what we want. And that means we need another global. And that is going to be scene state. And by default we will say we are inactive. And here we will determine... this is going to be fun. Yeah, it's so simple to say it goes from there to there, but... yeah... Zoom. Thinking. This would be a normal scenario where you might be going, say, from 10 degrees to 120 degrees, and so you can just simply compare the angle directly. If heading on the other hand, if the start angle is greater than the beginning angle, then we go... yeah, there's probably an easier math way of doing this, but it's 12:30 in the morning. I'll work it out tomorrow. Yeah. If heading is greater than... or... why is that the same? Seriously, oh, that brain dead. This is embarrassing. Paper time. I think it works because the angle automatically rolls around. I don't know. Now this also has to be a one-shot system. We don't want it to be constantly hitting that key to go scene switching once we're in there. So we simply go if I don't even need any of that. Might as well composite it all in one. No, making it more complicated. I could use XOR on this to flip the bit, but that's just a bit of fanciness. Let's keep it readable. I have no idea if this is I cannot speak. No idea if this is going to work. make, oh, errors galore, of course. Scene active, scene inactive. Oh, what else did I create wrong? 362. Helps if you put the braces in, Paul. Lo and behold, it ring. Okay, I need to be verbose. Start angle can be 90, end angle can be 180. Seems like we're active already. That would make sense. So here we go. So we're inactive. And what are we at? Start is 90. So we need to get below 180. There we go, we're active. Rotate it back. But you guys can't see. Of course you can't see. So here we go. Microscope now. Oh, we're being recorded. And switch back. And there. And switch back. So there you go. It works in principle. The next step will be for me to actually come up with the keyboard key scan code transmission so that OBS picks it up. But it's almost 1 o'clock. I think I'll stop this, upload it, and see what you guys think. Another boring programming video. But, you know, I would have liked to have recorded all the fiddling around with the I2C stuff, but honestly that took me about 8 hours of stuffing around throughout, doing other things during the day like paint fixes, MacBoard fixes, that sort of stuff. But yeah, sometimes you just can't get this sort of video footage done. So I'm going to leave it at that. I'll come back tomorrow with another part, and what I'll probably do is have it mounted onto the microscope by then, and then we can work on the actual integration into Open Broadcaster. So until then, you'll take care. I'll see you next time.